So here's our contract. This is the convention we're going to follow. We're going to push the arguments onto the stack, and when you call me, you'll put the return address, where you want me to return, into the linkage pointer. Okay? And since you put the arguments onto the stack, when I return to you, it's going to be your job to take them off the stack. So we have this convention that whoever puts something on the stack is responsible for taking it off, because they know exactly how many things they put on the stack. So they'll take exactly that many things off. So the caller puts things on the stack, calls, leaving the return address in R28. And then when the procedure call returns, the first thing it does is to take all the arguments off the stack. And now everything is back where it was, except I now have the answer from the procedure in R0. The callee, in other words, the procedure that you're calling, okay, I'll do the computation, leaving the answer in R0. When I'm done, I'll take that return address you gave me, and I'll put that in the PC, and that'll be the next instruction to be executed, or the address of the next instruction to be executed. I'll leave the stack just the way I found it. Anything I put on, I'll have taken off. Anything that you put on is going to be your job to take off. And then I'm going to leave all the registers exactly as they are, except for R0. So here's the actual little entry calling sequence. So the push, 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 put the arguments, do a branch, leaving the return address of the deallocate macro here, this instruction here, into LP. When the procedure call returns, this pops off the n words that I put onto the stack. Instead of doing pop, 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 since I don't really want their values, popping puts a value into a register. Since I don't want their values, I just say, just get rid of them all. Bulk disposal, without really caring about what the contents are. Entry sequence, I save the LP and BP registers. I make a copy now of the stack pointer, and that will become the pointer to the activation record of the current procedure. I go ahead and allocate other variables and save any registers that I want. And then to leave the procedure, I basically undo all of these things. So you can see each one of these guys here is really the opposite of what happened there, in the opposite order. Right? So if I push R1, R2, R3 on the stack, I pop them off, R3, R2, R1. And so this is really just undoing in the reverse order everything I did here to build the record. I'm now unbuilding it. Yes, ma'am?
So allocate just doesn't put things in, it just says I'm going to use these.
Right, so when you have something that says int x, int y, int z as a local variable inside your procedure, right? The compiler just allocates room for them. Then it's up to you to write statements that actually initialize them to 0 and 1 and 17.
But if you then want to use that allocated space, the way you put things on the stack is you push it, and that will do the...
No, so this allocate is actually moved the stack pointer. So those words are now safely allocated. Now you just use regular loads and stores to put values in and out. Push is when you want to sort of both allocate and initialize at the same time. Allocate just says, leave me room, and I'll use loads and stores to fill it up. Okay, and notice we don't really need an explicit deallocate, because this move of the base of frame pointer back to the SP, so the SP may be all the way up here, this move of the base of frame pointer to the SP sets it back. So that move is an implicit deallocate. Okay, so here's our favorite procedure, all carefully, you're going to get pretty tired of factorial, but all carefully written out. This was compiled using our compilation conventions, and you can see the entry sequence and the exit sequence, and in fact, okay, there's the entry sequence. Why did we push R1? Because notice this code down here uses R1, and because I have to return the registers in the condition I found them, the fact procedure, have to save away the old value of R1 so I can use it for whatever I want, and then before I return down here, notice that I will restore it. Right, so there's the entry, and here's the actual little calling sequence. Push the argument on the stack, do a branch, do a deallocate. Okay, so you should be able to use the calling convention, those little templates that I talked about, and understand the sequence of operations. Recursion, there's actually nothing very fancy about recursion. Okay, it's just like nested procedure calls. The fact that you're calling the procedure again with a different argument doesn't change in any way whatsoever how the stack frames are built. So you can see the activation records slowly be building up and being pushed being built onto the stack in last in, first out order. Okay, and they're deallocated in reverse order.